An n-gonal bipyramid or dipyramid is a polyhedron formed by joining an n-gonal pyramid and its mirror image base to base. An n-gonal bipyramid has 2 n-triangle faces, 3 n-edges, and 2 + n vertices. The referenced n-gon in the name of the bipyramids is not an external face, but an internal one, existing on the primary symmetry plane which connects the 2 pyramid halves. A right bipyramid has 2 points above and below the centroid of its base. Nonright bipyramids are called oblique bipyramids. A regular bipyramid has a regular polygon internal face, and is usually implied to be a right bipyramid. A right bipyramid can be represented as left brace right brace plus P for internal polygon P, and a regular n-bipyramid left brace right brace plus N. The face-transitive regular bipyramids are the dual polyhedra of the uniform prisms, and will generally have isosceles triangle faces. A bipyramid can be projected on a sphere or globe as n-equally spaced lines of longitude going from pole to pole, and bisected by a line around the equator. Bipyramid faces, projected as spherical triangles, represent the fundamental domains in the dihedral symmetry DNH. The volume of a bipyramid is where B is the area of the base, and H the height from the base to the apex. This works for any location of the apex, provided that H is measured as the perpendicular distance from the plane which contains the base. Only 3 kinds of bipyramids can have all edges of the same length: the triangular, tetragonal, and pentagonal bipyramids. The tetragonal bipyramid with identical edges, or regular octahedron, counts among the platonic solids, while the triangular and pentagonal bipyramids with identical edges count among the Johnson solids. If the base is regular, and the line through the apexes intersects the base at its center, the symmetry group of the n-gonal bipyramid has dihedral symmetry DNH of order 4n, except in the case of a regular octahedron, which has a larger octahedral symmetry group O of order 48, which has 3 versions of D4H as subgroups. The rotation group is Dn of order 2n, except in the case of a regular octahedron, which has a larger symmetry group O of order 24, which has 3 versions of D4 as subgroups. The diagonal faces of a spherical 2n bipyramid represents the fundamental domains of dihedral symmetry in 3 dimensions. DNH, order 4n. The reflection domains can be shown as alternately colored triangles as mirror images. A scalenohedron is topologically identical to a 2n bipyramid, but contains congruent scalene triangles. There are 2 types. In one type, the 2n vertices around the center alternate in rings above and below the center. In the other type, the 2n vertices are on the same plane, but alternate in 2 radii. The first has 2-fold rotation axis mid-edge around the sides, reflection planes through the vertices, and n-fold rotation symmetry on its axis, representing symmetry DND, order 2n. In crystallography, 8-sided and 12-sided scalenohedra exist. All of these forms are isohedrons. The smallest scalenohedron has 8 faces, and is topologically identical to the regular octahedron. The second type is a rhombic bipyramid. The first type has 6 vertices, can be represented as, where Z is a parameter between 0 and 1, creating a regular octahedron at Z equals 0.0, and becomes a dysphenoid with merged coplanar faces at Z equals 1.0. Beyond 1, it becomes concave. Self-intersecting bipyramids exist with a star polygon central figure, defined by triangular faces connecting each polygon edge to these 2 points. A P/Q bipyramid has Coxeter diagram. The dual of the rectification of each convex regular 4 polytopes is a cell-transitive 4 polytope with bipyramidal cells. In the following, the apex vertex of the bipyramid is A and an equator vertex is E. The distance between adjacent vertices on the equator E equals 1. The apex to equator edge is AE, and the distance between the apices is AA. The bipyramid 4 polytope will have VI vertices, where the apices of NA bipyramids meet. It will have VE vertices, where the type E vertices of northeast bipyramids meet. n-bipyramids meet along each type A edge. n-bipyramids meet along each type E edge. K is the cosine of the dihedral angle along an AE edge. C is the cosine of the dihedral angle along an E edge. As cells must fit around an edge, n-cos 1a circumflex symbol to I umlaut, n-cos 1a circumflex symbol to I umlaut.